Alright, third page. Use the graph of f to estimate where f prime is 0, positive, and negative. So, first derivative. Um, so f prime is 0. Right there and right there. So we'll say probably x equals 1 and negative 1. Um, f prime is positive. Right there and right there. So, how would we say this? 0. We'll say positive when you can. I don't care which notation you use. If you want to use interval or if you want to use inequality notation. So negative infinity to negative 1 and 1 to infinity, which means it's negative from negative 1 to 1. So you can see that here. So negative, positive, positive. Okay, easy enough. Use the graph to estimate when f double prime. So second derivative is 0. So f double prime is 0. You can tell. So if this is the graph of f, you can find when f double prime is 0 when you see an inflection point. So I see an inflection point just right here at x equals 0 because I can see that it's concave down here and concave up here, and at x equals 0 that's when it changes. So so 0 probably at x equals 0, which really just means it's concave down. So we'll say positive. So excuse me, let me explain here. So f double prime is positive when the second derivative is concave up. So here's concave up, okay? So the function's concave up here, which means that's where the second derivative is positive. So say x is greater than 0, or if you want to use interval notation, negative, then when x is less than 0, it's concave down. So that's how you can tell from the graph of f, where f double prime is positive or negative and 0. Find the dimensions of the largest open-top storage bin. So we're talking about volume with a square base, vertical sides, and vertical sides that can be made from 108 feet squared of sheet steel. Neglect excuse me. Neglect the thickness of the steel and assume that there is no waste. No, surface area would be the sum of the area of the base and the four sides. So if it's open top storage bin with a square base, it's five sided. So well, in any case, so since we're trying to optimize volume, let's first get that. So imagine that you have your square base storage bin or whatever. Okay. Oof, this is not looking good, guys. Let me try again. So, okay, something like this right here. So if it's a square base, then I'm going to call these sides xx. I'm going to call this right here y. And so volume, volume would be base times width times height. So in this case, x squared times by the height. So there's my volume, but I don't want it to be defined in both x and y. So we'll use another equation. Sounds like surface area is what they want us to go with. So surface area would be equal to, well, we need the base area, so that'd be x squared, plus the four sides, since these are all going to be, so this side will be equivalent to that side and all other four sides. So let's just do 4 times xy. And so that's the surface area. Okay, and so with a square so find the dimensions of the largest open-top storage bin with a square base and vertical sides that can be made from 108 feet squared of sheet steel. So that's how much that is right there. So we'll replace that with 108. And then we are going to solve for I guess we're just gonna trying to think of a good way to do this. I guess we're just gonna solve for y. 'Cause that's the only thing I think we really can do. Okay, so let's solve for y. So we're going to subtract x squared, so we get 108 minus x squared is equal to 4x. We get y is equal to 108 minus x squared divided by, sorry, that's 4xy, divided by 4x. Not very pretty, but we'll take what we can get. So we're going to replace this right here with the y. So we get volume is equal to x squared times y 108 minus x squared divided by 4x. And if we want to simplify that, x will cancel with an x from that x squared. Then we can distribute that x squared in x in there. So we get like 108x minus x cubed divided by 4. Right? So that's equal to 108x over 4 minus x to the third over 4. So this is our volume. I'm going to take the derivative of that because I'm trying to optimize volume, and if that's what I'm trying to optimize, that's what I want to take the derivative of. So we'll do v prime. So v prime would be equal to 108 over 4 minus 3 over 4x squared, and that is our derivative. We're going to set that equal to 0. I'm going to multiply everything by 4, which would just get rid of those, and it doesn't really matter on that side. So we get v prime is equal to 108 minus 3x squared equal to 0. Sorry, not v prime right there. And so then we get 3x squared is equal to 108. Divide by 3, take the square root. So we're going to get x is equal to plus or minus the square root of 108 divided by 3. I'm going to, I would think that the 108 divided by 3. Let's see if we, is that divisible? Is 108 divisible by 3? That's what I'm trying to think right now. Let me pull up a calculator, sorry guys. So 108 divided by 3, 36. So this becomes x is equal to plus or minus square root of 36, which we know to be plus or minus 6 inches. Since we can't have negative inches, we're just going to say plus 6 inches. Okay, so what's the question? Find the dimensions of the largest, so we're looking for the dimensions. Well, the base is going to be 6 by 6. How do I find y? Well, here's how we defined y earlier. So if we plug in 6 right there, so that's 108 minus 36. So 108 minus 36. So that's going to be equal to 72. Divided by 24. And that's going to be equal to 3. So the dimensions are 6 by 6 by 3. There you go. 6 by 6 inches by 3 inches. So that's the dimensions there. Okay, find the number of units that must be produced and sold in order to yield the maximum profit given the following equation. So maximum profit will occur if any maximum profit for a production level will occur if r prime of x is equal to c prime of x. So r prime will be equal to 30 minus, that's going to be 1/4 x, and c prime of x will be equal to 9. So 30 minus 1/4 x equal to 9. That's going to be 21 is equal to 1/4 x times by 4. So x will be equal to 84. Okay. I think that's everything. So next, let me read the problem. Find the number of units. Is it just 84? It doesn't really specify if the units are measured in thousands or anything, right? Yeah. Well, hold up. That's why something felt wrong the whole time. Sorry about that. Just circling back. Let me redo these derivatives. That's what was wrong. So we get 30. This is negative 1/2 x squared. It's not going to be 1/4. That's going to be, so 30 minus just x. There we go. And that's going to be equal to 9 when I take those derivatives. So 30 minus x equal to 9. So that's going to be x is equal to 21. Okay, there you go. So 21 units. Okay, there you go. Alright, so 15 C of x is, so we have the cost of some units manufacturing x items. Find the production level that will minimize the average cost. So minimizing average cost will happen when the average cost, which is c of x divided by x, is equal to c prime of x. So let's find the average cost. Average cost, I divide this by divide each of those by x. So c of x divided by x would be equal to x squared minus 20x plus 10,000. And c prime of x would be equal to 3x squared minus 40x plus 10,000. So if we set those equal to each other, and solve for x, let's see, if we move that over there, we're going to get 2x squared. Move, so it's supposed to be 40. Move that over there, we're going to get negative 20x, and then if I subtract, that's going to cancel. So that's going to be equal to 0. And so we can factor that. So we get 2x, then we're going to get x minus 10. So it's going to cost will be minimized when x is equal to 0 or x is equal to 10. X equals 0 doesn't make sense because obviously your cost will be minimized if you have no units. So 10 units. I think that does it there. So basically for these ones, just remember these formulas right here. So maximum profit, minimize average cost. Linearization. So find the linearization L of x of f of x at x equals a. Okay, so remember linearization is just a linear line, it's just a tangent line. So we're given a point that we're trying to find a tangent line at. So f of 0 will give us the y value that we need. So if we plug in 0, we're going to get the square root of 9, which is going to be equal to 3. Let's do f prime. F prime of x will be equal to 8 over 2 square root of 8x plus 9, which is equal to 4 over the square root of 8x plus 9. And if I plug in 0, so f prime of 0, this will give me the slope of my tangent line, so 4 over 3 is what it will be. So I think I have everything, so my L of x will be equal to slope times by x minus 0 plus the y-intercept 3, so it's just going to be equal to 4 over 3x plus 3. So there's our linearization. Kind of wish I did a problem where you actually had to plug in a number for it. So keep a watch out for that. I'm probably going to do something like that on the test, not just finding the linearization line, but one where you actually have to use the linearization to approximate a value of the function. So keep that in mind. Use linear approximation right here as specified. So find the linear approximation for this one right here. So I'm just going to get this to match whatever form this is, which will make it pretty easy to put it into that linearization. So this right here is equivalent to 5 plus x to the negative 1/2. So trying to think how we can do that part, because I don't think we want that to be 5. I wonder if we can take out of 5. So then that would be 1 plus x over 5. All that raised to the negative 1/2. Okay. That would make this a product. And if that's a product, then I can write it like this. So that's 5 to the negative 1/2 times by 1 plus x over 5 to the negative 1/2. Well, that would be equal to 1 over the square root of 5. And then that's going to be times by 1 plus x over 5 to the negative 1/2. Okay, that wasn't too bad. So here, I have it matching right here. So now I'm just going to write this part in that linear approximation. This 1 over the square root of 5 is just going to be a constant times by 1 plus k. In this case is going to be 1/5. K is the constant of the x. So 1 over 5x. Wait a minute, hold on. Let me backtrack a little bit. That's not what k is. So we have 1 plus k. K is the exponent. So 1 plus negative 1/2 x. And x is not x. X is going to be x over 5. And if we simplify it, we get 1 over the square root of 5. And we're going to get 1 minus x over 10. And there we go. So this is the linearization for this function right here. Okay. We have one more page, and I'm going to do that in another video.